How do we integrate the natural log of sine x from 0 to pi over 2? This is a heavy one, so if you can keep up till the end, then you're an integral master. That's my challenge for you. The first thing to notice is that the natural log of sine x has a non-elementary antiderivative, meaning the antiderivative cannot be expressed in terms of any of the known elementary functions. Also note that this integral is improper because sine of 0 is 0, and the natural log is not defined at 0. So at this point, we're not even sure if the integral converges in the first place. But let's assume that it does, and try to find the value for it. If we succeed, then our assumption was probably right. Okay? That's the plan. Let's call the integral I. And because this integral is definite, so there are bounds in the integral, we do have extra hope of finding an answer even if we don't know how to actually find an antiderivative for the natural log of sine x. Let's see what we can do. Looking at the bounds, we have 0 and pi over 2, and we know that sine x behaves very nicely in this interval. So this inspires us to use some sort of substitution that exploits this nice boundary setup, if that makes sense. And the substitution is u equals pi over 2 minus x. How does that help? Well, du equals negative dx, and if we write I in terms of u, we'll get this. Notice that sine pi over 2 minus u is precisely cosine u, because the sine and cosine are complementary in terms of the angle that adds up to 90. We can also use the negative sign next to the du to flip the bounds of integration, so the bounds are now from 0 to pi over 2. So notice that we have two copies of I. One of them has the sine x inside the natural log, and one of them has a cosine x. They're both from 0 to pi over 2, and they're both equivalent. Okay, so that's good progress. Let's add them, shall we? So we'll have I plus I, and we'll have the sum of the two copies. So 2i is equal to the sum of these two integrals. Now you may be wondering, one of them is in terms of x, and one of them is in terms of u. So how can we add them? That's actually not a problem, because u here is just a dummy variable for integration. So we can use the trivial substitution u equals x. And that solves the issue. Now we can combine these two integrals, because both of them are from 0 to pi over 2, and both of them are in terms of the same variable. We'll get the integral of the natural log of sine x plus the natural log of cosine x. And now we can see the reason why we decided to add the two copies. Note that we have a sum of two logarithms, and we know that the natural log of a plus the natural log of b is equivalent to the natural log of a times b. So let's use this property to express the integral as the natural log of sine x times cosine x. And once more, this reminds us of a very important identity. This time it's trigonometric. Notice that sine x times cosine x appears in the double angle identity for the sine function. Sine 2x is identical to 2 sine x cosine x. So the product of sine and cosine is equal to 1/2 sine 2x. So let's replace that in the integral. And now we can invoke the same property of logarithms to separate the product inside the log into a sum of two logs. We'll have the natural log of half plus the natural log of sine 2x. So now we have a sum inside the integral, so let's separate this into two integrals. The first integral is just the integral of a constant, so that's very easily pi over 2 the natural log of half. And then we have the second integral to worry about. But notice that the second integral is very similar to the integral we started with, except that it's the sign of 2x instead of x. So can we perhaps rewrite this in terms of I, the initial integral, which is the integral from 0 to pi over 2 of the natural log of sine x, or cosine x, by the way, because we proved that these are equivalent. So do we have any hope of rewriting this green integral in terms of the original I? Let's see what we can do. What comes to mind is a substitution u equals 2x, because if we replace 2x by u, then we'll have sine u. So that'll match the form of the original integral. But there's a problem with this, and it's the bounds. If we use this substitution, then this pi over 2 will become pi. The original integral is from 0 to pi over 2, not from 0 to pi. So we cannot use this substitution right now. Instead, we'll use something creative which allows us to use this substitution itself. How can we do that? We'll rewrite this green integral as the integral from 0 to pi over 4 of the natural log of sine 2x plus the same integral but from pi over 4 to pi over 2. Basically, we're breaking down this integral into two equal parts. And why are we doing this? Well, the first integral now allows us to use that substitution u equals 2x, because the upper bound is now pi over 4. So if you multiply it by 2, it will become pi over 2, which is indeed the upper bound in the original I. So this won't give us a problem. du equals 2 dx, and rewriting the integral in terms of u results in 1/2 the integral from 0 to pi over 2 of the natural log of sine u du. And now I hope you can agree with me that this is 1/2 I. Again, u is only a dummy variable for integration, so this is equivalent to 1/2 of the original integral. So we now have this second integral to worry about. But before we get into it, I think I lost most of you by now. So if you're still watching, then comment duck, okay? Just so I know who's still keeping up. Now, this second integral is a little bit trickier because the lower bound is pi over 4, not 0. So how can we use a similar substitution in hopes of rewriting this integral in terms of I as well? A creative idea would be to subtract pi over 4 first to make the lower bound 0, and then multiply by 2 to make the upper bound pi over 2 again. So again, subtract pi over 4 and then multiply by 2. In other words, to solve this integral, the substitution we will use is u equals twice x minus pi over 4. du will be 2 dx again, and the integral in terms of u will now be the integral from 0 to pi over 2 of the natural log of sine u plus pi over 2. Try to solve for x in terms of u and verify that this is the case. And now, similar to what we did at the very beginning of the video, sine of u plus pi over 2 is actually cosine u, because this is a displacement of pi over 2 units on the sine function, and this gives you the cosine. So can you agree with me once more that this is also half I? Because we showed at the beginning of the video that the original integral is equivalent whether there is a sine or cosine inside the natural log. So this green integral we set out to find is half I plus half I, or I. So we can replace this green integral with just I. And notice what happens. We now have a linear equation, a simple algebraic equation to solve in terms of I. We can just subtract I from both sides, and this gives us I equals pi over 2 times the natural log of 1/2. So this must be the value that the integral converges to. Now the final thing we can do is just use a property of logs to rewrite this as negative pi over 2, the natural log of 2. But that's it. That's the final answer. The integral we started with is exactly equivalent, or let's say converges to, negative pi over 2 times the natural log of 2. Please let me know what you think of this integral. Could you keep up, or was it too difficult?